Abnormal site. It's Dr. Bennett. Abnormal site. Dr. Bennett. Yeah, she's. Yeah, she's good. She's good. All right. So once you obtain your random sample, you're going to compare that random sample to the hypothesis that we stated, right? So if the average weight is um, in men is 175, right? We predict that the average weight gain is going to be 7, so it should be around 175, 182, right? So we get a average sample, we take that average sample, and then we see if there's consistency with the hypothesis. If it's consistent, then the hypothesis is reasonable, right? I can kind of support that. If the discrepancy is large, then the hypothesis is rejected, right? Go ahead. That's what we're going to get to. Because a large discrepancy, we have to set what that discrepancy would be, right? So we have, and I'll show you where I'm putting. So we have our normal distribution. Our averages here. And you set a region out here. So those critical regions is what the has to be larger. So this would be this in this region. So that means if the z-score is out in these regions, that means that it's large enough to reject the hypothesis that, right? So if it's out here, we kind of set our own critical regions and those critical regions. Stuff like that. You could based on maybe rating that they give you, right? If the rating, okay, is not does not fall into this, the average rating does not fall into this critical region, and the mean is here. But I know that if they rated eight or higher, but the average rating is around 5. But I know that if they rate 8 or higher, it's going to be in this range, right? That means I would probably go ahead and push the problem, right? Because again, it's a large enough discrepancy because the hypothesis says that it's going to be around here. But if the sample I get is out here, okay. You still gonna have to work with these numbers. So, kind of a basic situation. Here's an example. So you have the known population before treatment. Okay. The mean is 16. You have a standard deviation of 3. Okay. You administer some sort of treatment, whatever that treatment is. Maybe it's let's say it's a weight loss drug. Okay. You give the population or the treatment sample that weight loss drug. You then get the average score. Right? If it's a weight loss drug, here, I want this average to be less than 16. Just lay 11, right? Then we would use that 11 and compare this 11 to the 16 to see if it falls into this region. If it falls into this region, then I know that this treatment, weight loss drug, had an effect, significant effect on the individual treatment. And then I can administer the drug to everybody because I know it's effective. So that's how clinical trials work. They give a drug to like sample an individual that's kind of diverse. They check to see how significant the difference is, and then they administer it or they don't based on the difference. Go ahead. Yeah, they would control. There's no control. Yeah. They would control for those other variables because really all I want to see is they probably get a group of individuals who are at least similar enough so that I can compare them. Right? Go ahead. So the essay is what I haven't looked at on examples already. have to check. And sometimes you have to, if you come to class and say, hey, I have 131 students. I do apologize.
Oh, you're good. I got the notes and notes. Wow.
All right. Good luck with the car. I did. You too. Okay. Okay. So, the structure of research study, again, this is how we do it, right? You have a known original population, again, the mean of 16. You have a sample out of that population. You randomly select a sample out of that population. You then treat that sample, okay? Once you treat that sample, now you have what's called a treated sample. And if this treated sample, we're going to compare to this population, right? Because we want to see if this treated sample is effective in this population. If it's not based on the hypothesis. And I'll show you what these hypotheses are. Okay? I'll show you what the hypotheses are. So, know these steps. There are 4 steps to a hypothesis test. The first step is you're going to state your hypothesis. Okay. The second step is you're going to set the criteria for a decision. I'm going to explain all these in detail. So we got a few more minutes, and then we'll get out of here. The third step is you collect your data. You compute your sample statistics. The way that we've been in chapter 7, the way we computed our statistics, the standard error of the mean, you're going to compute the z-score. Those are your sample statistics. Okay, you know how to do that. And then the last thing is once you set your criteria for a decision, you collect your statistics or you compute your statistics, then you make a decision based on the criteria that you set. I'll show you. So negative 196 plus 1. Okay. This is a criteria that I set. If you would, go to 1.96 in your unit on table. Yeah, what does it say in the table for 1.96? All right. So this is 0.025, right? These extra zeros and extra zeros. Okay. And this is 0.025. Okay. So this is 2.5%. This is 2.5%. So conventionally, we use this as my criteria. Okay. So when I decide what my mean is, I compute my sample statistic. I'm going to compare my sample statistic, that z-score, to these values. And if these values, the value that I get from my sample statistic is in this region, then I would make a decision. Go ahead. That's up to the research. Some people use a 5% region. Others use a 1%. And you have some people that use 0.1%. And it's really based on your research and what you decide. It's not arbitrary, but usually this is this is what we call a two-step test. Okay. So that 5% is split in half. You got 2.5 on one side, 2.5 on the other. If it was 1%, then you would have a 0.5% over here and half over here. And that makes it a little more extreme. As you reduce your percentages, you have a smaller critical region. You have a smaller region here. So let me go to. So we're jumping ahead. Let's go ahead and jump. Let's go jump. on or 2, 3, 3. Well, we're get started to get fun enough. It's gonna be good. You might get started. Yes. Okay. So 0.1% is 2.58. Then you have 0.01%. That's going to be -3.30. So, right? So these are my critical regions based on those percentages. And those percentages are called my significance, or we call it significance. Or, but most commonly used is that 5%. Okay? At 1.96 plus or minus 1. Okay? It's a great question. All right, let's get to it. So, hypotheses. When we state a hypothesis, you have what we call a null hypothesis, and you have an alternative hypothesis. Okay, so your null hypothesis, H1 or H0, and you have a alternate, usually H1. Okay, the null hypothesis states that the treatment has no effect whatsoever. Right, so no change. When you say something is null and void, it means there's no change. Okay, the alternative hypothesis says that there is some type of change somewhere. Okay? So when you set your criteria and you find your sample statistics, when you compare your sample statistic to this region, it's going to allow you to make a decision based on is there a change or is there no change, or is there no change or is there some change in the data. Okay, when you're comparing. All right. So again, no change, some change. Here are different ways to speak about it. There's no change, there's no difference, there's no relationship. The independent variable of the treatment has no effect on the independent variable. Okay. And the alternative hypothesis is the exact opposite. Okay. So those are the two. When I ask you to state the hypotheses for your study, this is what I mean. You have a null hypothesis, you have a research hypothesis. Those are your hypotheses. Okay. This might be all we covered. So I'll finish this hypothesis. Okay, good on that. The second step, set your criteria. And this is exactly what we just did. Okay. So distribution of the sample mean divided into two sections. Okay. Those that are likely to be obtained if the hypothesis or no hypothesis is true. And so if the no hypothesis is true, that means there's no change at all. Okay. If the no hypothesis is true, the sample that I get should be in this region, in this white region, right? That means it's likely to be obtained. That's in here. Okay. Anything in this white region is likely to be obtained. Those that are very unlikely to be obtained, if the no hypothesis is true, are out in this critical region. Right? So we've set our critical regions based on, again, those 5, 1, and 0.01%. So again, like we said, alpha level or the significance level. Right? And the significance level is the probability that is used as a concept of variable likelihood. Right? So 5%, 1%, and 0.01%. And those are our very unlikely percentages. It falls into these critical regions, and I know it's very unlikely, it's very rare, and that I know that there's some change. I know that there's a significant difference. Go ahead. This would be the H and O, okay? Because again, this is likely. Everything. So this is how it is. So this would be the likely values. The straight region is that second one. These are the very unlikely. So you set the very unlikely. You set the very unlikely. So this is where the H and O would be, right? And then your H one would be kind of out here. Right? Because again, there is some difference. There are very unlikely region. And so anything falls out here, I know that there was some difference, some change, some treatment effect. Okay. But again, the commonly used ones, 5%, 1%, 0.0, point. Next week will be a lot easier, well, not easier. But once we start working some problems, it'll be easy to see what I mean. It'll come together. Yeah, we already wrote those. Yeah. Right. As a continuation for step 2, okay, these critical regions, these shaded regions, are the extreme samples. These extreme sample values out here will be a deep value in the critical region. And if you define those critical regions by the alpha level, 5%, 1%, or 0.01%. So it says, first bullet says, critical regions consist of the extreme sample values that are very unlikely these critical regions to be obtained if the null hypothesis is true. Right? So if the null hypothesis was true and my sample falls out of these critical regions, I know that that's very unlikely. Okay? Except the boundaries of the critical regions are determined by the probability set by the algorithm. So in 5% probability, 1% probability, 0.1%. Right? If the data falls, my sample data falls into this critical region, right? That's really important that we get our z-scores. Because once I get my z-score and it falls into this critical region, I can do what we call reject the null hypothesis. And by rejecting the null hypothesis, that says that there is some effect, there is some change, there is some difference. Okay? I know that if I can reject the null hypothesis by sample falling into this critical region, then I can reject that there is no change. Okay? So you have two decisions to make. Either you are rejecting the null hypothesis, or fail to reject. Okay. Those are the two decisions that you make. Reject the hypothesis. You take them. With a hypothesis, a hypothesis is never true or false because there is so much uncertainty when it comes to using a sample. The sample already has a lot of discrepancy and error in it, right? So there's already enough error already. And so we're just failing to reject it. The sample that we selected didn't have any change, but there could be another sample. If I got another sample, maybe that sample within the hypothesis script region, but we have to figure it out. Okay. This is exactly what this is. Okay. So the sample means are close to the mean here, and close to the null hypothesis here. Okay. These are high probability values here. Okay. And then in the orange region, right, extremely low. Okay. Extremely low probability. Right. That means that this is very unlikely. Right. And I would reject the null hypothesis here. My values is very, very low probability values. So these are high probability values. These are low probability values. Right? And so you want your samples to fall into those low probability values because that means that there is a change. There is a significant difference between the sample that I have and the population. Okay? Questions about this? All right, so what I just showed you, right? So again, you have the mean for our z-score is 0 in this case. Z equals 0. These are all my z-scores here. Okay. But our critical regions, 1.96 negative, positive 1.96, that is my 5%. This is 2.5, this is 2.5. Okay. Those are my critical regions. I'm probably going to show you an example so you can see it. Let me see if I can go over one example real quick. Well, let's do this real quick. It says a sports coach is investigating the impact of a new training method. In words, what would the null hypothesis say? So, sports coach is investigating the impact of a new training method. What would the null hypothesis say? The null hypothesis said no change. So, what would the inverse say? Good. Very, very good. It says the new training program produces results similar to the existing. There's no change. No change whatsoever. Okay. Any questions about that one? It's only, hey, only two. Only two. Two brave souls. Okay. It says the alpha level is decreased. The size of the critical region decreases. Good. Okay. What about the second one? So the critical region defines unlikely values if the null hypothesis is true. This one's true. Right? So these critical regions are based on the probability of these unlikely values, right? If this is actually true, right? So if again, my sample falls up here and my null hypothesis says that there's no change, I know that since it's very unlikely, I can reject the null hypothesis that there is actual change, right? So that's true. Yeah, that is true. Okay. All right. Yeah, the alpha is the portion of the area, the critical region, boom, boom, boom. All right. All right. This was not all that important, but collecting the data is the biggest thing. Your statistics are going to be what we learned before. You got your accuracy score. Okay. As long as you know those two things, you're good. Those are our statistics. Those are going to be our statistics. And once you know how to do that, you're good to go. Okay. Data are always collected after you state the hypothesis. So you don't state the hypothesis before, excuse me, you do state the hypothesis before you collect your data. You never collect your data, compute the statistic, and then set your hypotheses based on your data. That's backwards. Because then you're not proving, you're not supporting it. You're trying to set your hypothesis based on what you collect already. And that's backwards. Okay. Data are always collected after establishing the criteria, right? So you're always going to select either that 5%, that 1%, or that 0.01%. Okay. We want objectivity because if you don't follow the process, then it's very subjective. You can make your results be whatever you want it to be. If you go ahead and just change your alpha level, change your critical region, change your hypotheses after you collect the data, right? Then you're not objective anymore. You're really subjective. Okay. All right. So that's step 3. Again, you want objectivity. All right. So again, compute sample statistic, that's going to be our z-score, right? The difference between the observed sample mean, the hypothesized population mean divided by the standard error. That is what a z-score is, right? You know that, okay? But this z-score is our sample statistic. That is step 3, okay? Last thing, step 4, okay? Step 4. Make a decision. Okay? So the obtained z-score value is used to make two possible outcomes. And I talked to you about this before. Okay. So the sample data or the z-score I get is located in the critical region. And I'm going to reject the null hypothesis. Okay. On the other hand, if the sample data or the z-score that I get is not located in the critical region, right? Not located in the critical region, then I don't have enough data to provide evidence that the null hypothesis is wrong, and I fail to reject the null hypothesis. Because again, it's either supporting it or not supporting it. I'm not proving anything. I'm not proving anything because of the uncertainty in the hypothesis testing process or procedure. Okay. All right. Questions about that? I think I have one more thing to do, and then we'll let you all go. Okay. Let me finish an analogy, and then we're out. Okay. So, since the null hypothesis is either rejected or the researcher fails to reject the null hypothesis. So think about a jury trial. Okay. Since a jury trial begins with null hypothesis, innocent until proven guilty. Right? So the H null is innocence. And null hypothesis is innocence. Okay. Until proven guilty. The police, prosecutor, they get data, they collect data, they get evidence, right? To test whether the accused person either committed the crime or did not. If the person committed the crime, then that means you reject the null hypothesis. If you didn't, then it means you failed to reject. You don't have enough evidence to prosecute, right? That's the criminal justice system, right? You either have enough evidence to prosecute, or you don't. Okay? If you have enough, you reject no hypothesis. If you don't have enough, you fail to reject. Right? O.J. Simpson, they have enough evidence to prosecute. If it doesn't fit, you must quit. That's what he said, right? So they didn't have enough evidence. They didn't collect enough evidence, and it was a lot of evidence, but I guess it wasn't enough to prosecute. Okay, so with sufficient evidence against the defendant, you reject the no hypothesis, which is innocent, and you prove that the defendant is actually innocent. Right? They collected enough evidence. They proved or supported the hypothesis that yeah, he did do it. He or she in fact did it. On the other side, with insufficient evidence against the defendant, the jury fails to find the defendant is guilty. Right? So they don't have enough evidence. They must let him go. Let her go. They conclude that the defendant is guilty, is innocent. Right? So they got away with the crime. Right? All right. I think that's it. That would be, okay. That would be it. So that's going to be the exam. Hypothesis testing, know the steps. Know the steps. It'll be good. Know the steps. It'll be good. Okay. Any questions? I already put the what the steps are. You have to explain what the steps are. Yeah. Know what the critical reasons are. Know what those things mean. Okay. Any questions about anything? So I'm going to look at your rationale. I'm going to look at yeah, absolutely, absolutely. What's that? You will use yeah, yeah. So what you're going to do is you're going to look at you're going to review the study and see what statistics they used. And in this class, this is an introductory class. So the statistics they might be a little foreign to you, right? But I want you to look them up. Like they'll give you, we ran a regression, right? You want to be able to look that statistical analysis up and then kind of do some research on what that analysis is. And you won't know everything, right? But you'll know, they'll explain in the article what they did. And that's what you're going to be analyzing, okay? For review. All right. Yeah, it's new. That's good. Good for you. Just explain it. Just explain the concept. You don't have to do any math. Just explain the concept. Yep. Because a lot of the stuff that we're going to cover in this chapter or this class probably won't be unless you find a really simplistic research study that does a t-test, no correlation, then you might not find something that is specifically what we do in this class. Okay. But that's okay. And if you need any help me explaining it, I can do it. All right. All right. That is it for today. Homework 7 is posted already. I'm going to post the exam. I'm hoping by in the morning, so you'll have it. You'll be able to work on that whenever. Okay. You'll have until Sunday to complete that. Okay. All right. If you have no other questions, you all are free to go. I appreciate y'all. Y'all have a great weekend. Oh man, yeah, we had one on Zoom today. So, but yeah, so we'll gotta make it happen. Glad y'all showed up. You was going to take care of it.